What's going on, Hume 2 scholars? We're going to learn about the arc length today. Now, if you just use those two words, we know what an arc is. It's the measure around the circle right there. You see that from A to B? That's the arc. And so to find that length, you can see it's in bold. The length is a fraction of the circumference. So what does all that mean? Well, let's look at our formula, which is coming up right here. And the formula for arc length is, m over 360 times 2 pi r. And the 2 pi r, if you were thinking critically, you should think, oh wait, that's the circumference part, right? So all of these ideas tie together. That's where you see that circumference. And then the m is just the measure of your angle. And then of course we put it over 360 because there's 360 degrees in a circle. Perfect. So let's see how this works. Find each arc length. All right, so the first thing we always want to do is write our equation. So the equation, or the formula, is arc, or we can just, arc length equals, that's AL. Siegel's always thinking. Measure 360 times 2 pi r. All right, and now let's just plug in what we know. We know that our radius is 5 centimeters. See, it's marked right there for you. And we know that our angle is 50 degrees. So now we just plug everything in. So for that m, we're going to plug in 50 degrees over 360. And then it's going to be times 2 pi times 5. And from here, you're just going to plug it into your calculator, making sure that you leave it in terms of pi. So Siegel's going to do that for us right now. He's working it out. So remember, you don't mess with the pi. You leave the pi alone. So what you'd put in is 2 times 5 times 50 over 360.
This?
Yep. Times the 2 times the 5. And then you leave the pi separate. Treat it like a variable. Treat it like x. So 28 over... Oh, here, let me scroll this down, Siegel. That way they can see. There we go. We're having technical difficulties. Thanks for being patient. There we go. 25 over 18 times pi. And then you leave it like that. On IXL, they'll have you leave it in terms of pi.
So in IXL, they write it like this. 20.
Yeah, in IXL, they would write it like that with 25 pi over 18. So if you need help writing it in the actual computer, just ask Mr. Siegel or myself. All right, so that's that one. Let's look at number 4. 4 is the exact same problem. You want to go through this, Siegel, just so they can see it? All right, so let's write our equation. It's AL for arc length equals, x over 360 times 2 pi r. We know our radius is 7. We know our angle measure is 100. And so now we're just going to plug everything in like we did before. So I have 100, over 360 times 2 pi times 7. And then from here, you're just going to, once again, 7. It's good. See? We make mistakes. It happens. Don't worry about it. And then leave the pi by itself. So when you plug this into your calculator, you'll put 100 over 360 times 2 times 7. It's going to give you, here, see, I'll give you some more room. There you go. $35 over 9 times pi, which in this case you'd write it as 35 pi over 9. Perfect. Well, let's see what else they can throw at us. And so now in this case, we're trying to find the actual angle. So that's what we're looking for. We don't know that. But we're still going to write our equation. So AL equals the measure, or x, over 360 times 2 pi r. Now what did they give us? Well, they gave us the arc length of 15 pi. And they gave us a radius of 18. And so those are the two things we're going to plug in. So where do we plug in that 15 pi?
The arc length.
We plug it in for the arc length, right? So we're going to plug it in on this side. 15 pi equals the angles that we're looking for, so that'll stay as x, over 360 times 2 pi times 18.
Oh, sorry.
And the radius keeps 18, perfect. And so now what we're gonna do is, so now what we can do is we can cancel the pi's on each side, and that leaves things nice and easy. And then we just, so we have 15 equals x over 360 times 2 times 18. And now we wanna get that 360 out of there, so we'll times both sides by 360. Those 360s, or the 360 on the right goes away. And on the left, we're left with 360 times 15. And then we do that in our calculator, and we end up getting, I'm doing it in my head. Hold on a second, scholars. Give me just a second. It is, what is it, 5,400? 5,400, is that right?
Yeah, you nailed it.
Oh, nice
Gotta
job.
do the calculator.
Yeah, that was tough. That was a hard one. And then times 2 times 18, which we know 2 times 18 is 36. So we get 36x. How do we get x by itself? Divide by 36. And we end up with x equals, oh man, this one might be hard. 150? 150?
Yep, nailed it.
I don't know how I do this. There you go, mental math, guys. Great job. So we have 150 for that one.
Yeah, that's it.
Do it, or that's good?
Let's just set it up. and
Let's
then
just
the
set it up. All right. Yeah, we're gonna set this one up for you. Oh, it's all the way down here. So same idea. This time though, they're asking you to find the radius. So let's write our equation. AL equals m, or m over 360 times 2 pi r. Our angle is 175, and our arc length is given to us as 105. So for AL, we plug in 105 pi. The measure of the angle is 175 over 360 times 2 pi, and then r we don't know, so we leave it as r, or we can call it x. And so then from there, you could still cancel pi's on each side,
And they can solve that.
and then from here, you would just move things over and get x by itself. So here's your IXL, and that is how you find the measure of arc lengths.